Hello, everyone. This is day 4 of week 2 of India evening and weekend platoon. Today's lesson is Intro to OOP. But before we get into today's lesson, I'd like to just go over any questions you might have from Thursday, which I believe it was just TDD with pi test. Any specific questions that apply to any of the 3 problems that you solved? Any questions on TDD itself?
It seems like it's a really slow way to code. Is that something that you actually use in the workplace? I went on Reddit and I saw it was like a war between devs on opinion.
Great question, Logan. That question leads me to believe you're actually thinking about this, which is really, really good. Um, it's kind of one of those things where people say to do it and nobody does. That's the truth. Uh, although, if you work on good teams, they won't accept your PR without tests. So it's kind of one of those things where, okay, you figured out the crux to the problem, you've solved it, you've tested it. All right, so now you have to write tests. Typically it happens the other way around. Like I'm sure there's some really great teams out there that really follow it to a T. I have yet to be on one of those. Everyone says, yeah, 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 yeah. I never do it. You ever go to a restaurant and you realize that no one ever washes their hands before they eat? I'm like the only one. And then when I started doing it, I've dated my girlfriend for so long, then she started doing it. But I was like, we're like the only ones. But you were taught that in kindergarten, right? No one does it. It's
Yeah,
kind of
that's
like
some
that. It's
serial that's like serial killer vibes, man.
yeah, yeah, yeah,
Well,
that's kind of how it goes. Next time you're in a restaurant, you're going to be thinking about that though. Um, anyway, yeah. So that's a whole TD. Great question though. That was actually kind of the question I was hoping someone would ask. Because that's the obvious question, right? Any other questions? It's hard to top that one, but yes. Any other questions about the specific challenges or like the crux to any of them or what PyTest is? Just the testing framework. You guys went over Jest in JavaScript, right? Other big languages have their own testing frameworks that you'll use. If you use Java, you use Maven or I forget the other one. But yeah, they all have their own testing frameworks that they use, and depending on the use case, they'll tell you, hey, use this testing framework. And then when you send up a PR, you'll send up tests that cover everything. Pretty much all the edge cases and all the what they typically call happy routes and sad routes, or they have a multitude of different names. Happy cases, sad cases. What's linear search? Just briefly go over these ideas that you really need to know.
Just whenever there's a search that goes through an array or a list, I mean.
Yeah, yeah. It's just tagging every element, checking for something. Hey, are you this element or do you have this? Right? Tagging every single
Yeah.
element, typically in a list. Um, or if you iterate through a dictionary, tagging every single element. Although, what's wrong with that statement? Iterating, iterating over a dictionary. What is wrong with that statement?
Isn't with dictionaries that when you compare between a list and a dictionary, a list is doing it sequentially by index, and then like a dictionary, it's not sequential like it is on the list.
Perfect. This direct access, right? You wouldn't ever iterate over a dictionary. Why?
It
Does
might be
everyone understand?
huge.
Yeah. Right. That defeats the purpose of having a dictionary. The whole power of an object or a dictionary or a hash map or however they name it in their specific programming language is the fact that you can access the values directly. Right. So if you find yourself iterating over a dictionary, there's probably a better way to do it. Make sense? All right. Linear search tags is actually a really important one for a multitude of different things, but you're going to realize that a lot of the built-in methods that we covered, was it last week? Uh, Under the hood, they're just a linear search. So you have to keep that in mind. right? For example, when you have nested loops, you'll have two linear searches that are nested, right? And sometimes people don't think that's a big deal. It is a big deal, right? It's exponentially worse. Um, and we can do an example of that later. But just know linear search, super important. Roman numerals is kind of a challenging problem. Can anyone tell me the crux to solving that problem? We're not going to go over it, but did anyone solve it and tell me what's the crux, like what's the main thing you need to figure out to solve that problem?
How many times to push one of the Roman numerals?
Yeah, that's one of the big ideas. And the second one is how do you match? I kind of don't want to say it that way. How about this? How do you map the specific Roman characters to numbers?
So when I was doing the exercise, I was trying to separate, make them in the list and then separate them and then match them. But then when we started going over it and talking about it, then then they pointed out it was better just to make a dictionary. And I was just like, why didn't I think
Yeah,
about that?
yeah. Map it to a dictionary. That's those two things that were mentioned right there are the crux of that problem. And if you go backwards, it's a little easier because you can just decrement. So if you didn't get that, that's okay. That's kind of a challenging problem this early on. So if you didn't get it, that's okay. But that's something that if you have extra time, definitely go back to. This idea of mapping things happens all the time, right? Of mapping certain keys to values happens across software a lot because it helps to, and this is an idea we're going to cover today, it helps to abstract a lot of complex logic for the end user. And when I say end user, that can be anyone. That can actually be someone sitting at home trying to use your application, or a lot of the things that people don't talk about is like typically everyone here, if you end up getting a job as a dev, depending on where you go, it's highly unlikely that you're going to work on something that's like customer facing. You're probably going to work on some kind of internal tool or something. Does everyone understand that statement? There's a lot of code that's used in the world that people don't see. I'll give you an example. I work for AWS, but there's only been one thing, right, that anyone would ever see, right? You say, hey, what have you worked on? I'll mention this really small thing and I can go to the public website and be like, hey, this I worked on. But outside of that, right, everything that I've worked on is internal, right? Other devs use it or they're, you know, well, typically just other devs or other teams use it, which is kind of like something that I guess if you're not in doing development work, you wouldn't know. I hope that makes sense. So yeah, internal facing. Alrighty, so that's Roman numerals, and the other one is just PyTest, just a testing framework. We're going to use PyTest a lot. We're going to use just a lot, so get used to it. But they're pretty straightforward. All right, let's start with today's lesson. Can you guys see my screen? I have the Python OOP. Yes.
Yeah.
Okay. All right. All right. So what we're going to cover today is probably one of the more challenging things that you're going to learn in this program. I personally think it's the most difficult, right? But depending on who you ask, right, they'll say, well, top 2 or 3 most difficult things. And I'll give you the top 3 things we get from students that are typically the hardest in the entire program. OOP, React, and then sometimes Django with the databases and the schemas. So unequivocally, that's kind of the top 3 things we always get. I think it's this one. So try to focus on exactly what today's lesson is about, because this is one of the hardest things you're going to have to learn. I don't say that to scare you. I just say that so you understand what you're going into, right? This is kind of an abstract thing to understand. All right. Python OOP, object-oriented programming, is one of the most effective approaches to writing software. Uh, so in object-oriented programming, you write classes that represent the real-world things and situations. You create objects based on classes. When you write a class, you define the general behavior of the whole category of objects can have. We're going to talk about writing classes today. I'm going to try to simplify this as best as I can. So there are 5 pillars of OOP, but I'm just going to glaze over this because they're not that important right now. And then later, I'll show you specific examples of all of them. All right, so these are the 5 pillars. Encapsulation, when data can be restricted based on needs. Encapsulation, one of my favorite examples, and this is not the most basic example. Sometimes, anyone ever ask you to like write a solution to a coding challenge and you start doing this? Oh, this is Python, right? Right, you just start writing a bunch of code. You guys ever do that? Right?
I hope to get to that point one of these
Yeah.
days.
Exactly, right? And we learned the other day, right? If it was me telling you, you start doing this, I'm going to say, hey, write a function. Why would I say, hey, write a function?
Because you're gonna want it to do an action, basically.
Yeah, but this is doing an action, right? If I just start writing some code here, right? This is going to do, I can print, some
So you can separate it from other pieces to make troubleshooting easier.
Yeah, that's kind of the key word there. So you want to separate it. So you want to here kind of encapsulate this code, right? Because if you just wrote code like this, there'd be no way to call it. Like when you executed the file, everything would just run, right? Now it doesn't have a name. What if I get more complicated than what we learned the other day and I have index2.py? Now I ask you to import it. How are you going to do that? It doesn't have a name. That gets really messy, right? So in programming, you will encapsulate everything. And the biggest piece of encapsulation is classes. Now, encapsulation applies to a lot of different things, but that's the first thing. I want you to think of this example first, right? You would never write code like this. You write it in a function, right? And then you wouldn't normally just write a bunch of functions in a file, right? You write classes to build real world things that have properties and methods are just functions. Does that make sense?
Can you say that again?
Yeah.
From the function
Right.
part and then how you broke it down?
Yeah, so you could just start writing code right here, but you wouldn't do that, right? If you were doing like a coding challenge and you start writing code like this, someone would probably say, hey, write it in a function. And then you'd be like, okay, def, find, rjust, some param. And then you'd start putting all this code in here, right? Because now if you have that, that code has been encapsulated in this function, right? Now I can import that specific function, right? But to take that a step further, you never have just like loose functions in an application. You encapsulate everything in classes. Does that make sense? So this, to me, is like the easiest example to understand for encapsulation.
And
we're
when
going to
you
get
say
into. Go ahead.
I was saying when you say you separate them into classes, that's not like you're just saying like you separate them like in certain buckets, right? You want to keep it together, or is that actually like underneath a syntax when you say you separate them into classes?
Thinking them as like code buckets is fine for now. Yeah,
Okay.
more or less. Right. You ultimately want to separate all the code, right, for a multitude of different reasons. And really the main reason, right, is organization. And ultimately the architecture of your application. Right.
Doesn't
And then
it, doesn't
go
it
ahead.
make it easier to use too? I mean, reuse, you can reuse it
Yes,
a lot
right.
easier.
Remember the example that I gave earlier. If you had this, there'd be there'd be no way to reuse this loop, right? You can't call it, doesn't have a name. You can't import it to other files. It would only work if everything was in the same file, but you're not going to have 10 million lines in one file.
And then earlier you said, you said you're gonna go put it into a function first, so that way you can separate it. Then and I forgot what words you used right after that. You said put it into functions, and then after functions, you'll do. And there's two other things you brought up. And can you recall what you said
Yeah,
earlier?
so you wouldn't, just like you wouldn't write just a loop without it being in a function, you wouldn't write a function without being part of a class. And that's kind of the
Gotcha.
last stage of OOP. And that's what we're going to learn today. Everything will be encapsulated within classes. And we'll show you why in a second. It's just how you organize your code.
Gotcha.
All right, so that's just kind of a simple example of encapsulation. The other one is abstraction. Logic and complexity is hidden for simplicity. My favorite example of encapsulation is just your GUI. Your GUI on your Windows or your Linux or your Mac. All that is abstracting uh, a lot of what's happening in the background, right? When you use a terminal, very few things are abstracted away, right? You can just, check whatever it is you need to check, right? This tells me a lot. This tells me the user that's on this computer. This tells me a bunch of permissions, right? This tells me when it was created. This tells me what files are in there. Like your GUI does that, right? But you don't have to type a bunch of commands, right? In the GUI, how do you navigate a GUI?
You
Click.
point click.
You click. All the
It's
complexity has
like
been abstracted away. You click away, right?
it's like going from
That's
MS-DOS to Windows when that whole thing happened.
I'm not familiar with that, but it's possible it's very similar. All right, so encapsulation, right? Abstraction. Inheritance is sharing similar features or attributes. The key word here that you have to remember is just is a. We'll do examples of inheritance, but it's just when like a certain block of code inherits functionality from another block of code. That way you don't have to rewrite it. And we're going to go over that in just 1 second. Composition is including other objects as attributes. That's kind of when a block of code, right, has another block of code in it. And I know that's really abstract, but we're going to talk about it in just 1 second. And then polymorphism is objects can take different forms depending on their needs or situation. And that's another thing that's kind of abstract, but we're gonna kind of talk about it in a second. And we're going to give examples of all of this, right? So let's just kind of get to the real world, the examples of all 5 of these pillars here. I'm going to open this here. Oh, not that. All right. You can follow along if you would like, but I'm literally just going to go through this. This is, for example, just an example of dog class right here. That's it. Does my dog class have any attributes, any properties, any methods at all?
No.
It doesn't have anything. What happens if I print Fido here?
Probably undefined. You may get it undefined.
All right, let's see.
Never tried it before. Oh, no such file or directory. What? Oh, it's your index pi doesn't know where it is.
Why is that happening?
Uh,
The 2 tenets of Linux.
Yeah, where am I?
is this Linux?
No, this is right. Yeah. Hold
You
up.
have to use Python 3, I think.
No, I aliased mine. So everyone here
Oh,
should have theirs aliased. So give me a second. Not sure why that happened. Let me open it again.
Forgot about alias.
Uh, I- I'm checking my other terminal. It's perfectly fine.
Hmm.
Let's try that again. Yeah, there
There
you
you
go.
go.
That was weird.
Oh, it
I think
prints the object. Yeah. Okay.
I think I deleted the folder Python and then just created another Python object. I think it just didn't read it. Right. All right. Everyone can see my screen, right?
Mhm.
All right. So this right here is telling you, hey, there's a dog object, and this is just the place in memory. That's all it is, right? But it's telling me it is an object. All right, cool. So that's just how you create an object. And this is just code. Remember how you write the syntax for writing a function? Def, function name, parentheses, any parameters, colon, enter, just syntax. That's it. I'm going to write a class. That's it. A class can be viewed as a concept or a blueprint for some idea. When you turn the concept into reality, we create instances of the class, right? How do you instantiate a class? Well, it has to have an init method, right? And this is an example of this. So this, I'm going to spend a little bit of time on because it's a little confusing. Now it actually has a method, right? When I say method, I just mean function. It just means it's part of a class. That's the only thing method means. It's a synonym. All right, so here I have a dog class, and here I'm instantiating the class, which just means I'm creating a class and calling it Fido. So here, when I go to the variable named Fido and I grab its property name, it actually prints Fido. Or yeah, Fido. There you go. You see it in my terminal. So now I actually have a class, have a dog class whose name you can create. But here's the thing about creating classes, right? You're not limited to the number of classes. So I can create some other, well, let's give him a name. Let's call him Benji, my brother's name's dog's name, right? And I create this other dog because he needs a friend, and his name is Benji, right? Now, if I run this code, I'm going to get what in the terminal?
Two instances, the one named Fido and one named Benji.
Yep, there you go. I missed the print statement, but yeah, there you go. So now I actually have two instances of dog. I have Benji and I have Fido. That's it. So this is kind of like a template for how to create a dog. Go ahead.
if you had printed self.name, what would you get?
Great question. If I go in here and I print self dot, this is what you mean, right?
Just without the Benji.
Just self dot name.
Yeah.
It's throwing an error. Why is that?
There's no
Um,
reference. There's like self of what? That's probably what it.
If you hover over VS Code, it says self is not defined. What does that mean? I think Brian kind of touched on that a little bit. What does that mean?
Self's only defined in your function up top in the class.
Exactly. So that's a really important thing. It's only defined in the class. It's not defined anywhere else, right? I don't think we talk about it yet, but I want to go ahead and mention it. It has to deal with scope, right? That variable only exists in a certain scope, right? And if it doesn't exist in that scope, it doesn't have access to it unless you specifically tell it where to look. Make sense? It's kind of like the Linux thing. When you're trying to execute a file, but you're not in the right directory, it doesn't know where to look for it.
so if you tabbed it in one and did it, would it work? So that it's in the same line as the function above
If
it?
I print it in here,
Yeah,
right, and I print what, self name,
yeah.
and I print what, self name, right? 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 And I pr If I print self name here,
Oh, it's just
and I
gonna print name.
just print name.
Data print the name.
Oh, no, I meant self.name will just probably print name, I guess, or no, name's a variable and name's not defined. Huh.
Your
Okay.
thinking is along the right lines. Keep that in mind. That works. All right. So this is really kind of just people always like give the car example, kind of like a factory for dog objects. The classic example you always see in all the literature is like a car. It's like a factory of cars, right? We did dog here, but you could easily say, car. And then here you could easily have, brand, make, miles, color, whatever the case may be. And I haven't actually fully looked at this, so I'm sure we'll get something very similar to that. All right. So just think of it as kind of a template for creating these type of classes. And the classes can be anything. Here I gave you a dog example, but I'm sure later on we'll do examples of a bunch of different things.
I forgot. Does Python let you declare variables under class? Can you declare field variables or field attributes like above the function? Can you define attributes? Like right under class, if you put self dot breed under dog, under class dog.
For right now, don't do it.
Okay.
I don't think it's this lesson. Right?
Okay.
For right now, just stick to this because I don't want to confuse you more than you probably already are. All right. So we can have instance attributes, like I was saying earlier, and this is literally just a souped up version of our dog class here. What's the only difference here from this and what we've been printing before or working with? I just have more what?
Variables.
Yeah, but they call them instance attributes, right? So if I run this, I still get, right, Fido. But now I don't just have name, which is what we had before. I have breed or color, right? So if I wanted to print Fido's color, what color is it for this specific dog?
White.
White. But if I had a different dog, right, and it wasn't Fido and it was Benji, this can be a completely different color, right? So if I color for, let's go brown, right? This is going to be brown. And that's because it's a different instance of dog, right? Fido and Benji are both dogs, right? But they're not the same dog. Make sense? All righty. All right. So this is instance attributes. You add them like this, and they're just variables, right? So you give them a variable name and you add this self prefix to it. What is self-referencing in this class? Does anyone know? I haven't mentioned it.
Reference. It's reference to the function.
No, it's
Or to the class.
referencing.
The
Yes.
variable.
It's referencing the class. It's referencing itself, right? So that's what this self color is. It says, hey, in this class, I'm going to have, right, this instance attribute, right, called name, right? And I'm also going to have breed. I'm also going to have color. I'm also going to have sound, right? So when you instantiate, i.e. create a class, right, you need to pass it these four things. All right. So here, let's take Fido again, but let's remove Wolf here. And now it only has these three arguments. If I run this, what happens?
You gotta change Benji to Fido.
But after I do that,
It should give you just the three that you put in there, right?
let's see. What does it do?
Air it out because you're missing an argument in the last one.
Yeah, it's telling you, hey, I can't instantiate or create this dog class because it's missing a positional argument named sound. So you can't actually, this is an optional the way that I wrote this, right? So it's required. So I have to give it a color.
It would be optional only if you gave it a default value then, right?
Correct. And now you're starting to piece together everything we're learning. Yes.
So the fact that you got to have self dot variable name within that instance as the attribute, does that imply that you could have attributes in there that are not from within this class?
Yes, but you're jumping ahead.
Okay.
Yes, we're going to get to that. And that's ultimately how you organize code, right? That's how all the 5 pillars of OOP kind of come down together. All right, instance method. And a method is just a what?
Function.
It's just a function. That's all it is, right? And that's the only thing we're adding to this exact same dog class, right? We added all of these attributes, right, which are just variable names that are referencing itself, right? But now look what I gave it. I gave it the ability to speak and fetch, right? So if I print speak and I print fetch, right? I should get those strings, right? And I do, right? I get wolf and I get fetch. And I actually didn't realize that I didn't need these prints. They're already built in. That's why I'm getting those nuns. Because when I call that function, the print statement's already there on line 10 and 13. Right. So I get wolf and then I get Fido fetch the ball. Because I called speak, right? And what is the difference between these two functions?
Calling different function.
Yeah, they're calling different functions, but that's the obvious answer, right? Well, one of them takes something and one of them doesn't.
Argument.
One of them takes an extra parameter and one of them doesn't. Look at speak. When you write a function, it needs to include self in it. That's just the syntax. Don't overthink. It's just the syntax of how you write it in Python, right? So it's going to take itself, right, as a default, always there parameter, right? And then fetch actually takes one that you have to pass in, which is an item, because it wants to know, hey, what are we fetching? In this specific, we said ball, but if we wanted to fetch a hot dog, it doesn't really matter. See, now Fido's fetching a hot dog. Remember last week when I mentioned that ultimately you don't hard code anything in functions. Everything that the function needs, you're going to pass in as an argument or as a dependency. You see the same thing happening here because then I can reuse the classes and whatever it is that they need, I can pass through them. And they're reusable, easier to maintain. Does everyone understand how that's all starting to fit together?
Mm-hmm.
So this is a lot, and that's okay if you're a little overwhelmed. But as long as you're more or less following right now, I think you're going to be fine. Speak, fetch, right? So now we have these attributes, but now we also have these methods. So we're able to create dogs that have a name, they have a breed, they have a color, they can speak, they can fetch, right? What's another thing a dog does?
Dig holes.
No, not my dog. My dog bites,
Eats.
You
right?
got a mean dog.
Bites, and then mine takes a victim name, right? And it prints grr, just ate. Who do I want to eat? Name, victim name. Right. So now if Fido bites, well, what's a really biteable person? Sarah. I don't like Sarah's. And I run my class again. Gur just ate Sarah. It could be anything. And here you can kind of start to see, right, how code develops. I can give it anything. This just happens to be a dog class. But it can be a class of anything, and it can have any attributes, and it can have any methods or functions. It can do anything. Now I can start to map the real world with the virtual world.
I'm having a hard time trying to, and the transition from init with the attributes listed under it, and then how it transfers to the next function. So like, I understand, I get the class dog. So I was trying to just kind of break it down. Like I get, okay, class dog, we're starting a class now. Boom, this is going to start a class, and then the function starts to this function def init it is beginning to categorize the type, the class, and then like I guess the type of attributes that this class is going to have, right? I think is what I'm following. So then, and I get it. Like, okay, this class is going to have this dog is going to have itself. It's going to have a name, a breed, a color, and it's going to have a sound. So whenever we make a dog, these are the type of attributes the dog can have under this class. I think is what I see. But where I get kind of a little bit lost is where we start to go self.name equals name. And I know we're just calling or we're creating those attributes there. I guess to me, it looks like a backwards variable. I still am not trying, I still can't interpret what we mean by self.name equals name, and then how all of a sudden we go to the next couple of functions and we call self and then self item and it's so I don't know if I'm the only one, but I'm trying to follow as much as I can.
So this isn't a reverse variable. It's just a variable, right? It's exactly the
I see
same.
what you're
Really,
saying.
there's only one difference, right? Is the fact that it's referencing itself as a prefix, but that's just the syntax of how you write it. That's it. There's really nothing more to that. At least nothing more than you need to understand right now. And here, let's just stick with this right here. Just
I guess
lines
that's
1 through 7.
I guess what throws me off is that I see the period, so self dot name, and that's the first time I've seen where the beginning of a variable is has a period in it. But that you're saying that doesn't even matter. That's irrelevant.
It's not irrelevant. You want me to break it down to you? It's not really going to make more sense. But yeah, self just references the object being created, right? And then name is
Gotcha.
just the instance for this object. And then name actually comes from here. You're
Gotcha.
assigning it
Okay.
to whatever's being passed in. So if you follow it, look at line 18. Fido is coming in
Yeah.
as name. Pointer is coming in as breed. White is coming in as color. Wolf is coming in as scent. Then there's just referencing its own attributes and assigning it to this stuff.
That makes sense. Okay, gotcha. So when you say
Yeah.
self, it's calling the class. So that's what it's trying to call in.
No, it's just referencing the class that's being created. Because here,
Okay, gotcha. Okay.
right here, class, dog class is being created here. So the dog class is being created right there, right,
Oh, I see what you're
right
saying.
here. And
Okay.
the only thing I'm
Yeah.
doing is then I'm assigning it to a variable name called Fido.
Okay. Okay. All right. I see. I see. What we're doing is we're building the structure of this class. It could be anything. It could be cake or whatever, but like we're just building like the structure, and we're just gonna lay in whatever it is that. Am I
Yeah, you
understanding that right?
yeah, you're just building a class, right, to eventually use it
Gotcha.
for something.
Okay. Gotcha.
Anisha, go
So
ahead.
Oh yeah, sorry. I was just it took me a long time to really understand self because like in JavaScript you have this. And the best way that it was described to me as like a pronoun. Like I'm not gonna go around and say, Venetia eats, Venetia, blah, blah. I'm going to refer to myself as I'm going to go eat, I'm going to bark, whatever. So, like, self is similar because your class isn't going to just keep talking like that. You're just going to say, I'm going to bark, I'm brown, whatever. So, that's the best
Gotcha.
way that I could understand it.
That's actually a really good description. Go ahead, Tony.
So for this, right, when you're saying equals name, breed, color, sound, when you plug that in on the backside of the self dot, that's what's calling it to print, right? Like, so meaning whatever you identified it as or whatever you're saying to print, whenever you're calling the self dot sound, that's where it's calling to print it for that specific object, right?
Yep.
Okay.
This is just referencing its own class because the speak function is a method within the dog class. So when it says self sound, it says me, my class, call sound.
Yep. Okay. Thank you.
There you go. Good questions. So that's instance methods. We discussed instance attributes. We discussed instance methods, right? Some important things to observe about the instance methods we added in the code above. Notice, and this is kind of the part that's a little confusing, notice that every instance method includes an init. This takes in a parameter named self. This parameter is a reference to the instance calling the instance method, just pretty much just calling itself. Note that we can name this parameter anything that we want, but my naming standards is called self. This is just, it's known as a convention, is what you call it. Like here's something kind of weird. Like here, if I run this function, what do I get? Hot dog?
Fido and Pointer.
I get Fido. Why?
Is it because you're overriding the default?
No, I'm not overriding anything. But what I'm here to show you is these are just parameter names. They can be anything. They follow the convention of being what name and breed is because that makes sense. It's easier to follow. But it actually doesn't matter what these names are. Now, would you ever name them hot dog and donkey? No, because that's confusing as hell. But nothing stops you from that. Same
Now,
thing with self. Go ahead. Go ahead, Nicholas.
could you have also changed it to self dot hot dog equals hot dog, right?
Yes, you could have, but you wouldn't normally do that because of convention and other issues that it would cause. Right here, I'm
Yeah.
just trying to show you that, hey, learn the convention because that's the way that you're going to see it. Not necessarily because Python will hold your feet to the fire necessarily, depending on what it is. Python's actually more or less pretty good with it, but if you JavaScript is a notorious one where it just lets you do way more things that you probably shouldn't be able to do. That's what I'm like. in real application, no one uses JavaScript. They use TypeScript. I hope I didn't confuse anyone with this.
Yeah, I had a go around for this one. Sorry, I'm on two instances on my computer because our internet's being worked on, so I have to be on my cell phone. But I'm still tracking on the file, the READMEs. But I guess I was watching a couple of YouTube videos yesterday, and I guess just for anybody else that's kind of confused with this too, I guess the best way that I saw something just like kind of that this is used for is like, let's say you're making some sort of app, right? And you want to describe all your users, right? So this could be like a way to kind of list out attributes that you can call to each user, right? So if you have like, I guess, you're starting to build out some sort of like, I don't know, let's say it's a shopping app, right? And you have, you want to start building out the different types of things you're selling that you can call back to, or different type of user logins. This is kind of something that's kind of what I saw it be used for in these examples. Is that sort of like a real world thing? Uh, I guess that's what I'm trying to wrap my head
Yeah.
around.
Yes, and that's actually one of the last things you're going to do today. You're going to build a little simple guessing cadence right here. I'm not going to go into it right now, but that's ultimately you're going to start creating something like that. But yes, we haven't got there. You're jumping way ahead, but yes, that's where this gets to. All right, if you followed all this so far, you're in good shape. Like, there's a little bit more complexity to this, but this is a good place to be. All right. We talked about init. We talked about parameter names, right? Obviously, don't name this hot dog and donkey, right? Stick to the naming connection, name and breed, or whatever it is for your class, and you'll be just fine. Other dunder methods. Other dunder methods. Let me copy this. Python classes come with a bunch of built-in methods that we can leverage for our needs. Built-in methods, someone just rattle off a couple examples of some built-in methods in Python. Type.
Print.
Yeah, type, right? What else? Map, reduce. What else? There's a bunch of them, right?
Zip.
Zip, that's a good one. Those are built-in methods, right? Init is just another built-in method, right? It allows you to create that specific class. We already did this. What happens if we print a class? What do you get? We did this right at the beginning. Anyone remember?
You just get the object.
Yeah, you just get the object and then the memory address. That's it. But that's actually not particularly helpful, especially when you're trying to debug. So we're going to try to see if we can do a little bit better here. All right, so we're going to print Lassie here. This is just kind of just an extension of our class that we've been working on. If I print Lassie here, what's happening?
Where? Oh,
Is it Python going in, seeing that the dunder method is calling itself, and then using that method to list out name, breed, color, and sound?
Yeah, let's try to do this one at a time. Good. Let's comment this out and try to do this a little slower. Okay, this looks like the class that we had earlier, right? Now, if I run my code here, I am going to get exactly what we discussed before. Hey, this is an object and it's at memory address, whatever. Cool, right? But notice when we add in this really sweet built-in method from Python, that's dunder str, and we add it. Now, if I print the same thing, look what we got. I'm a golden collie named Lassie, and I say roof, right? This is just a built-in method you can add to any class that's going to help you, right, develop. Because that's all this is, right? When you're developing an application or you're working on a project, right, this is not particularly helpful. Main.dog object at memory address. But this, when you're building out an application, right, or you need to give some output to the user, is much more helpful, right? Just like we have map, reduce, type in Python, right? We have other built-in methods as well that apply to classes, and that's what you're seeing here in the SDR method. And you can add this to any class, and this can be any string. And this is really just to help the developer. That's it. Just know that those exist. Those are known as dunder methods. 2 underscores together is known as a dunder. That's why it's called that. 2 underscores together, known as a dunder. Are generally meant to be called directly by our code. Python automatically will call the appropriate dunder methods for us, depending on the operation performed. And the only difference in this class that we didn't have earlier is just this method or this function, right? That really, this is just an F string. This is just an F string that lists out all of the attributes so the developer can see them or the user.
So when you ran it earlier, how come it didn't run? It didn't do the speak function or the fetch function.
Can anyone answer that question?
Because it wasn't defined in the thing, right? Like you didn't call on it specifically.
I didn't call on it. Lassie is not speaking, but it can. Line 21.
Okay, I think that right there just made me understand everything, the whole
If
thing.
you-
Sorry, go ahead. Oh no, what I was saying. So when we just called the class, there is nothing, no function that. So when we did print last originally, and we didn't put the speak function or the fetch function. Those I understand now. Those didn't pop up because we didn't call those functions. All we called was the original init class. So, and there's nothing that said print from that under that function. So
Yeah.
then it gave you that error. Okay.
You don't want to call, and that's kind of the reason why when I was showing you earlier of
That
just
makes sense.
writing code that's not encapsulated in a function, that's just hanging around in some file. That's why you would never do that. You don't want it to execute what you don't need it to execute, right? You want it to execute
that's
upon command.
That's like a reference book in the library. It's there. It's not to be checked out. It's not to be anything, but you could go back.
It doesn't do
Okay.
anything unless someone acts upon it, right? So here,
Okay,
now we have,
that just boom, just now I get it.
so now we have Lassie that's speaking, right? And it's fetching a hot dog for some reason. And then I also is printing the dunder method here, just really for the developer. Right now, you're going to build little terminal games, so it'll be, for the developer / end user, but that's typically what it's for. All right. In this lecture, we covered the basic understanding of the following: what OOP is, what are the 5 pillars of OOP, how to write a Python class, how to create an instance of a class. Now it's time to utilize what you've learned. But before we get into that, right? I kind of wanted to give you one more example. Let's see if we can do the classic example. Okay. Let's do the classic bank example is like a bank. That's one you always get. All right. So if I want to write a class bank, we gave the let's call it bank account. We gave the example of a dog, right? But another really classic example, there's like 3 famous examples: the car example, the dog example, and the bank account example. But let's start from the very beginning. right? And let's write our very own bank account class. This is not in the README. I just want you to walk me through it. What's the next function I have to write?
Yeah, do
So-
the init.
Yep. I have to do my dunder init method, right? And this is going to take 2 parameters, which is the first one. Well, it's going to take self, and then a bank account typically has a what?
Account number.
Routing number.
It has a bunch of different things, but let's keep it simple. Let's just stick to how much money is in it.
Money.
Balance.
Yeah.
Balance.
Let's just stick to, and we can get into everything that you just did and start really going crazy with it, right? And this is something that's actually not in the README, but typically, all right, so the following is a convention of Python. When an attribute is private, you actually do an underscore on it. I've seen it with a dunder and an underscore. Let's just do a dunder. A dunder is just 2 underscores, right? And it'll be something like balance, right? And balance. That's it. So my bank account is the variable name, and I am going to create a bank account. How do I do that?
You would say
Call class.
All right, I'm going to call
You
the
put
class.
bank account. Yeah.
And this takes how many arguments?
2.
One.
Self and balance.
1.
Yeah, 1. I'm sorry. 1.
It takes 1. And if I print my bank account and I run this, what do I get?
Should get 50.
No,
Get the object, I think.
you get the object of the memory address.
Yeah.
We need the str to do what.
Index2.py, sorry, index.2py. Let's try that again. I changed files. All right, so I run this and I get
Yeah.
bank account at
You're
that
not
object.
printing. You're not
There's
printing out.
nothing else in here. This is the only thing I've written, but as you guys mentioned, right, there's a lot of things that come with a bank account, right? There's routing numbers, there's the actual bank account number, there's the company bank, there's a million other things. We're not going to get too complicated, but if I have a bank account, right, I have a bank account, it'd be super cool if I could do just like 1 or 2 things with my bank account. And what's 1 or 2 things that you do with a bank account?
Deposit and withdrawal.
There you go. Let's write a deposit function. Deposit, it takes self because it's inside of a class. Let's reference the class itself. And then I'm going to deposit some cash, right? Some cash, yes?
yes.
And then this function is going to do what?
Add to the balance.
Add to the balance, yeah. So I'm going to go self. Now, don't let the underscore dunder mess with you, or the self mess with you. This is just a prefix, and the dunder on these methods just means they're private methods. I don't want to get into it right now, but it's just an attribute that's not meant to be accessed outside of the class for right now. And if you didn't understand that, that's okay. Just get comfortable writing it this way and get comfortable with the syntax. So here, I'm actually going to add some cash to that balance, right? Yes?
Mm-hmm.
Yes.
It'd be super cool though if I could have if the user could check balance, right? I can deposit, but I don't know how much money is in there, right? So right now I printed bank account, but notice there's no way for me to check the balance. I know that when my class was created, there's $50 in there, but I should be able to check, right? Let's write a check balance function. Check balance, right? Take self, and it doesn't really need anything. I just want it to print just my balance. My balance is, and then just give me the balance. All right, so I just wrote a bank account class. I instantiated my bank on line 13. I created it with $50, and then what do I have to
Check
write
balance.
on line 14 to check how much money's in there?
You do a print check balance.
Print check balance, not quite, we're missing something. Throwing a squiggly,
Class name.
The argument, my bank account.
my variable name, but yeah, my bank account dot check balance. Now, if I run this, I get my $50. I actually get more than that. I get my balance is I messed something up on line 14. What is it?
So you use dot notation instead of passing the argument into the function. Does that matter?
Where specifically?
Like where my bank account is on line 14? What if you put that after check balance in parentheses? Are those two interchangeable?
No, 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 no. They're not interchangeable at
Oh.
all. Look at my instance. My
You remember your-
instance, give me a second, Brian.
Yeah.
My instance has a name of my bank account. I cannot run a function without referencing where that function is, and it is encapsulated in my bank account. So this is right. This is my variable name for the class, my bank account, which I created. Check. There's an error on line 14. I need someone to find it. That's
I know
not
what-
it though. Go ahead, Brian.
Missing a parentheses after check balance
Why?
because check balance is a function.
Yes.
It's easy to do.
So now it says my balance, right?
Because you got the print, you don't need it.
Yeah, I don't actually need the print. I keep forgetting. I keep doing that. But yeah, I call check balance. Remember, check balance is a method, right? It needs a function call. We run it. It says, hey, my balance is 50. Cool. So I check my balance after this, right? And if I deposit, now I can deposit cash because I have a deposit function. Someone run me through the code on line 14 to add $100 to my bank account.
So it'd
You
be
do,
my bank account, yep. And then you would say equals space equals deposit. Or
You're getting there, but no equal sign. Dot,
Oh yeah, dot deposit.
then
Then you'd have to, I don't know. I'm kind of stuck on this point. To close it out. I
deposit
don't
is a
know.
method, right? So all
Yep.
methods have a function call. And this one actually takes an
Yeah.
argument, which is it takes an argument of some type, which is $100. So now if I run this, what do I get in the terminal?
150.
Yeah, you got to print it.
Yeah, I printed it already.
Because the print is within the function. That's why you don't have to say
Yeah.
that.
Yeah.
Yeah.
So and the thing is, I keep screwing it up. Print statements. I don't know if anyone's covered these yet, but print statements are just for the developer guys. Like it's just when you're building out. You're not actually going to have real print statements when you're writing real code. Does everyone understand that? Right. And you're like, oh, well, when you're developing, yeah, when you're developing locally, once you send it up to whatever server your application is running on, you'll have built-in logging and a bunch of stuff. So you won't actually have any print statements. And actually you'll get flagged because a lot of people tend to print like credentials and like API keys and stuff like that. So that's why I keep messing it up because I'm not really used to doing it. Right. And this function, like this right here, we're learning how to write classes, but print doesn't do anything code-wise. It just shows you, the developer, right? If this is a real function, this would be what kind of statement? It wouldn't be a print statement. It'd be a
Return.
return statement. Yeah. All right. So there you go. This is not in the README, but we just literally just created it, right? It created a little bank account class, but I have balance, right? But if I wanted to create it, this can scale, right? I can have bank name here, account number, account number balance, right? And I just have I just did it with balance just to make it easy, right? But this, you can see how this starts to kind of add complexity. You can have a bank name, right? You can have all the things that like a real bank would have, right? Well, account number, account number, right? I still want to create that same account. What am I missing on line 15?
$15.
You need all the new, um, you need to add information for all the new things you just added.
Yeah, let's do Wells Fargo. Let's do just this string, Wells Fargo. That's my bank name, and then account number is just 1, 2, 3, 4, 5. Right. So I just added, right, this information. So now when I run this, this actually still runs, right? And my balance is still 150. And if I want to write another function, say def name bank, I could, and I could just print my bank is, whatever your bank name is, right? Here it's bank name. And I keep screwing that up. Right, so now I can comment these two things out, and I just do my bank account dot aim bank. And then bank doesn't actually take any arguments at all. Right, so now I can run it, and my bank is Wells Fargo. Yes.
Yep, I get it now. 15 minutes ago, I was a soup sandwich, but this I get now.
Okay. Give me 1 second. We talked about encapsulation and what it is, like wrapping your code in these nice little blocks of information, right? Abstraction is kind of what you see here on line 21, 19, 20, 21, right? The end user doesn't type stuff out, right? To like go to the bank, right? But under the hood, right, all of this information is being abstracted away. Right. When I go to my Chase Bank, whether app or Wells Fargo app, whether it's on my phone or on the computer, I'm just clicking buttons, right? I owe my buddy $20 for some beer. I just sell him $20, right? But think about, let's just talk about Venmo. I don't work at Venmo, right? But if you go into the Venmo code base, right, there's going to be classes like this, a class of users, a class of payments, a class of maybe payment history, right? A class of friends. On your Venmo app, you have a bunch of friends that you've sent money before to, right? All those are classes. Now they can be, again, I don't work for Venmo, I don't work for PayPal, right? But just looking at their app, you can start to kind of think about what kind of classes they would have. This is a classic bank account example, right? So this class exists somewhere in every major banks. There's a class called bank account that has a bunch of methods, adds a bunch of attributes. Any questions about abstraction or encapsulation?
So when we talk about these instances, I just want to make sure I'm understanding it right. Like you're instantiating an instance of it, and then when does that instance actually go away? Like, is there at any point where I mean, I know on a modern computer, we're probably not going to run out of space just doing something like this, but is there a point where you have to do some type of collection, garbage collection or anything like that?
No, not for Python. You start getting into Java or some of the other slightly more complex languages, there's tools built for that. I
Okay.
wouldn't worry about that right now. Simply because just even getting good with architecting some more complex solutions is actually really hard. And actually, very few people are good at it. Not necessarily because they're just not good devs, but just because they're not given the opportunity, right? To work on really big data intensive problems with a lot of code and a lot of requests, right? If you work for a really small company, you're probably solving very small problems. But if you work for like a company like Netflix, right? Like you have to be a really great engineer to get into Netflix, but the people who come out of Netflix are incredible engineers, right? Simply because of the problems that they're having to deal with at scale, right? Just on a macro scale, just think of how many people, I think they have hundreds of millions of daily users on Netflix across the globe and how they're able to deliver with a great deal of success all that content. Those are enormous problems. Kind of went off the rails a little bit, but I hope that answered your question. So the code is always there, but it's not always running. Like if it's running somewhere, it's running, right? And it's taking up resources, right? But if it's not being executed, then it's just taking up memory. It's just sitting somewhere. I think that probably answers your question slightly better.
Yeah, that's good.
Mhm. All right, so that's encapsulation, abstraction. Inheritance, actually, I'm gonna have to look at the assignment, but we can cover it very briefly. The easiest example is really just, let's do animal. Let's write a class animal. Class, it can be anything, doesn't really matter. Okay, let's do class animal. What is an animal? What's the next thing I have to write here? I'm writing a class animal. It needs a what?
Init statement.
Yeah. Init method, init, it's going to take self. And this animal can have just a name. Let's just give it a name, right? So self, if you don't want to use the dunder right now, that's totally fine. It's not going to break anything. Just know eventually that's something you'll have to do. All right, so this animal, this is some animal. I don't know, some animal. And I'm going to instantiate the class and I'm going to give it a name. I'm going to give it Max. All right, and then I'm going to print some animal. Cool. And then I'm going to run this. And what am I going to see in the terminal? It's an animal object and it's at something, right? And that's because I don't have a what?
Print statement.
An STR statement.
Yeah, I don't have the built-in str method.
Oh yeah.
Right here, I could literally just, let's just do print and I'm going to do my name is whatever. And here, his name is Max. So if some animal, actually, I don't need that. I'll do that in the next class. All right, so now if I print it, what happened here?
It doesn't think your str is a string. So I think yeah. Maybe you have to use double quotes. I don't know.
That won't matter here. Let's look at our look at the syntax on the right.
Oh, you
The
gotta
return.
return, yeah.
Return. And this is just returning a string. And this is a built-in string method that Python gives me. Let's see if that was the error. Yes, that was the error. This built-in method that Python has, right? You don't have to print. It's always going to print it in a terminal. It's built in. It knows that, hey, this is for the developer and he needs to see it or they need to see it. All right, so this is just an animal. It just has a name. It doesn't do anything else. That's totally fine, right? A dog is a class of animal, right? Yeah. All right, so I'm going to write a dog class, and I want it to inherit from animal. This is inheritance. This is just a really simple example, right? It's going to inherit from animal, right? And this is going to have just a method called byte. It's going to take self, and it's just going to print, right? Grr, bit someone. All right. So I created an animal here, but what if, right? What if, right? I created Benji. I created this dog, right? This is inherentness right here. A dog is a animal. Where is this? Right here.
So then it'll print out everything that's in the class. So it'll be like, my name is Benji R bit
That,
somebody.
yep, that's the right answer, right? So a dog is an animal, right? This is an example of inheritance, right? So I will go ahead and inherit all of the functionality of animal, right? And maybe I have also some added functionality here, which for Benji is, for this dog is byte. Doesn't have to necessarily be Benji. Right?
Yeah.
So let's give animal, let's give it a method though, called speak. And speak is really just going to be, hey, my name is, you know, hey, my name is, let me slow down here, right? If I print some animal here, some animal, and I call speak on it, I am going to get what?
Hey, my
Doing?
name is.
I
Keep
don't
going.
see anything that's uh
It's going to print. Hey, my name is Max.
Yep. Hey, my name is Max. That's some animal, right?
yeah.
Gotcha. Right. So that's some animal. And if I created, right, Benji, oh, I have it here. Created Benji. If I created Benji and I do Benji.speak, if I run this, what do I get?
Where's dog at?
Would
Oh,
would you
arg bit someone.
I said with the print, you already have the print statement within the
Oh yeah. Yep. I keep
this
doing
the
that.
speak.
Oh yeah. Yep.
But I'm going to leave it in there for now because I'm going to change it here in just 1 second. Oh, actually, I have it there too. Never mind. I don't need it. If I run this code, what do I get here?
Arg. Hit someone.
No.
Should be, hey, my name is
Oh, not speak. I'm
Benji.
sorry. Speak. Speak. Oh yeah. Yeah. My name is Benji. Okay, my name is Benji.
No, it didn't. We didn't pass an argument to give it a name. The dog,
So,
Mhm.
right?
so Benji needs to have a name called what?
Oh,
Benji.
that's
Let's
right.
call it Benji.
That's
Let's call it
right.
Benji. Okay, let's try that again. What method does Benji have?
The init method, is it?
They both have init methods. Yeah,
It inherited all the methods of animal and then the one
yeah,
that you gave it, right?
that's it. I don't really
Okay.
want to go any further than that. Notice, look at my class dog. Look at my class dog. It does not have speak, right? But it somehow has the ability to speak because it inherited
Inherit.
from animal. What
If you-
if Benji was to bite? Can it bite too?
Yes.
How does inheritance work if you went like a step further down this tree?
Man, I was kind of hoping no one would ask that, but I can give you the business if you want. Um, we're this class is getting kind of long here before a break, but I'm just gonna do a quick one, so then we can get to. Actually, I'll give this one, then we'll take a break, and then we'll come back and finish out the class. Okay. This starts to get really deep depending on what kind of application you're running. I'm going to give you the simplest example that I can think of. Right. Right. Yes.
Mhm.
I hope to don't lose you, but you asked for it. So here we go. Right. Class quadrilateral. Quadrilateral is a what?
Class.
Yeah, but it's a quadrilateral. What is it though?
The shape.
It's a shape with what? A quadrilateral
Four
only
sides.
has
With
one
laterals.
shape with 4 sides, right?
Sides, yeah, yes.
Yeah.
Yes. Okay. Cool.
Yes, that's it.
Class rectangle.
Mhm.
It's a shape with 4 sides.
There you
with 2
go.
longer
Okay.
than the other
Okay.
2.
Okay. All right. So can a class of rectangle inherit from quadrilateral?
Yes.
Is a rectangle a quadrilateral? Yes.
Yeah.
Yes.
Mhm.
Has 4 sides. Has 4 sides. Right. Has 4 sides.
That are not equidistant or
We're getting to that. Right.
It's a
So
four-sided figure where all the angles
I'm
are
not-
90 degrees.
yeah, we're not there yet, but we're going to get there. Right. There's a class quadrilateral, but a class rectangle can inherit from class quadrilateral because a rectangle is a quadrilateral. Right. All right. Let's keep going with inheritance. Class square. Is a square a quadrilateral?
yes.
Yes.
Is the square a rectangle?
No.
No.
Actually, yes.
Rectangle.
Yes.
Oh, yeah.
Yeah, it's got 4 sides at 90-degree corners.
There you go. That's what defines a rectangle. Now,
Yeah.
the only difference is that people mistake is that a square is just a special kind of rectangle, right? It's where all the sides are the same
Equal.
length, right? So
Mhm.
this is where I'm going to stop, but this is an example where you can go 3 deep, right? And I could have gone I could have gone off, dude. I could have done class shapes, man. Is a quadrilateral a shape?
Yes. They're all
Yes.
shapes.
All the way down to atoms, basically.
Yeah. So you can do it almost at an infinite number of times. Now that's going to, depending on what you're writing or what the use case is, this can get very complex, right? So you can
Yeah.
kind of see where like reusability of code and code readability and just simplicity is really hard to attain, especially when you start scaling out applications. And you always talk about scaling big applications because guess what? Big applications make a ton of money. Like if you work on an internal tool that 10 people in your company use, that doesn't make any money. It might be vital to your company, right? But it's probably not that valuable. However, if you work like on a big application that's delivered to millions of people, right? That's going to make a lot of money.
Do you have to like, so let's say square is everything above it. Would you have to like method chain like shapes dot quadrilateral dot rectangle dot square, or is it just square inherits everything that's kind of in that chain above it?
If quadrilateral inherits from shapes
Mm-hmm.
and rectangle inherits from quadrilateral and square inherits from rectangle, square has inherited everything from everything above it.
So you don't have to mention them in your
No,
like function calls and everything. Okay.
there's a super init method that you eventually have to use, but yes, it's literally one line of code and it inherits everything above it. We haven't got there because we've already kind of gone too deep in the rabbit hole. But yes, this is what would happen. All right, that class, I'm going to pause. Stop sharing screen. That went way too long. There's two more things we need to cover when we come back. But after that, I'm going to cut you loose and we're going to do individual work for a little bit. And then, wait, I guess I didn't. Oh, no, I did pause it. And then we'll do a little bit of peer programming and then we'll come back. But that was way too long. Come back at 10, go grab a breakfast taco, whatever. And then I will open up the rooms. I'm going to open up the rooms in a way where you can jump into any room. So go ahead and after 30 minutes, come back, get into your breakout rooms, and then we'll do a little bit of individual work and then some peer programming. That work?
Sounds good.
Recording. I definitely lied to you. I said we were going to breakout rooms after this. We're definitely not doing that. We're doing that, but just not right now. Let me just cover two quick things here. I know nothing about this lesson has been quick, but just the nature of this. Alrighty, can everyone see my screen?
Yep.
Yep.
Alrighty, so let's look at this. We're looking at our right-hand side here, which is going to look at the 5 pillars of OOP. Talked about encapsulation. We talked about abstraction. Talked about inheritance just now. Let's briefly talk about composition. Look at the screen right now on the left. This is an example of composition. And the key word to remember for composition is just has a. Look at our two classes, an engine class, and then I have a car class. And a car has an engine, right? When I run this script, take a minute, look at it. What should I get into my terminal?
V8.
Not quite. Look at line 13.
Should be engine started. Oh, V8 engine started.
No, you had it right the first time.
Oh, okay.
It's engine started, so let's walk through it. The first class we have is just a simple class that when you instantiate the creation of this class, it just takes one parameter type. What type of engine, right? There's a bunch of different type of engines, 3s, 4s, 6s, 8s. I think there used to be like 10s and 12s back in the day. I don't remember. I'm not a car guy. But this is just a simple class and it has one method, start, and it just returns the string engine started. That's it. That's the entire class, right? But then we look that we create another class called car, but a car has an engine, right? So, hey, Let's just instantiate the creation of that class inside of another class. Cool. So now we create car, C, right? We get its attribute engine and we hit the method start. So it says engine started, right? Because we instantiating the creation of a different class inside of a class. Object-oriented programming. This is more or less the crux of the whole thing, right? Those 5 pillars that we discussed. So far, we've discussed 4. Why is this possible? Because everything in Python is an object. Has anyone ever seen the Python object meme? This one here on the right. It says everything in Python. Wait, it's all an object? Always has been. Anyone ever see that before? Okay. Well, I know it's probably not that funny to you, right? But when you understand OOP, this is supposed to be kind of like a meme joke, right? Like it always has been, right? It's because everything in Python is an object. And I know this is a little abstract, right? So I'm going to give you one more example that hopefully doesn't confuse you. Look at this code and just take a minute and read it. Think of what the answer is here when I execute this line.
Okay, I got it. I think I got it.
What's the answer?
So it's going to be 3 times 4, 12, and then you add 3. So it should be 15.
It is 15. Can you walk me through how you got that answer?
All right, if we go backwards, so here we're saying at the very end we're calling some function. So I kind of did like backwards. So okay, I went from some function and I went back to that function and I took a look at the 2 parameters. The 2 parameters I see for some function is take some function param and then add number, which here, if you go back to the print statement, that take some function param is actually molt. And that calls another function. So, and then the second parameter of some function is add num. So add num is exactly 3 if you take a look at the print statement. So 3, we can leave it. We don't have to reference back 3 anymore. 3 is as is. It is what it is right there. So then if you take a look at molt, right? Molt is its 2 parameters are num1, num2. So whenever molt is called, there has to be two parameters that are inputted to it. So if you go right back to the second function, some function, it says that take some function. Those 2 parameters that are given are 3 and 4. So basically, whenever you call molt, you're returning 3 times 4, which is under take some function, and then now you add that because it says it on the second function to add num to 3, which is the second parameter on the print statement.
I was pretty close to perfect. Question. Why is this possible?
It's because each one of those functions is just passing the return value of some other function around.
And everything in Python is a what?
Object.
Yeah. You can pass functions. A function is just an object. It's a variable, it's an object. It's a list, it's an object. You can pass them as parameters. So this right here, it's not any different. Understanding the concept that everything is an object, this makes sense. Could then I create a class collection, car collection? Line 20. Could I?
Well, on line 17, you have it as a list. And so the only thing I would say is, how would you get name of collection added to that list? Because right now there's nothing that says that adds it to it, I think. Am I saying that right? Or because right now you have self.name of collection, so it'll take the name of collection from the function. But there's really nothing that adds
Because I haven't finished.
car.
That's what I'm asking. Line 20.
Yeah.
That's exactly what line 20 says. Could I then start adding cars to my collection? That's the only question that I'm asking.
Yes,
Yes. And why can I do that?
because everything in Python's an object.
Yes. And all object-oriented programs have that ability.
So I have a question. I'm sorry.
My bad. So I guess I was gonna ask in that case, for if you did want to add to your collection, right? On line 16, would you have to have some sort of like numeric value of number of cars, and then just like plus equals that in underneath if you're counting your cars?
Yeah. Yeah. You could. I don't want to get that deep, but you absolutely could. I specifically didn't add this method, right? But yeah, you would just add it. Remember bank account? We just added to a bank account. We just added $100. You remember that one? But that's just an object. I could add a car because it's just an object too. Now, is that car going to have a bunch of nested functionality? Absolutely. But conceptually, it's no different.
So on line 19, why isn't car capitalized? Like, why aren't we using the class, I guess?
Great question. Great question. Logan, you're quickly becoming my favorite student, buddy. That's a hell of a question. Can anyone answer that? Why is this lowercase car and not big case car, big capital letter R?
Because you're passing in a car and not referencing the car class.
Car would actually, so this is what gets kind of confusing. Car here is just a parameter name. This could be donkey. It doesn't matter what it is. I called it a car because it is a car, but that car parameter can hold anything. It can be an integer, it can be whatever, but given the context of what we've written, right? This is a car, right? And the biggest problem that you're going to run into going through these assignments and eventually building out your applications is you're going to lose track of what's a parameter and what it holds. You need to be able to follow this code to know that, hey, when I just look at these very simple 20 lines, car here is going to be a car class, right? And just look at that. That's what naming is so important. Right now, I'm just giving it whatever names, right? But that's what's really important, that you name things what they are. Because you're going to have to, right now it's 20 lines, it doesn't matter. But a real application, you're going to follow a variable across dozens of files sometimes. And not just variables, right? Big classes.
So I guess I have a question on whether or not does that mean you want to be either super specific for like a class naming, right? And then kind of generic for others. So for example, like if you are building a collection of cars, would you want a class of vehicles, right? And then if you have some of them are cars, it's kind of okay to generalize car as opposed to the main class would be like vehicle collection or something.
Get as specific as you need to. That's the general rule of thumb. For right now, it's not, it's really more important that you understand the concept, right? Like, take this example. This is, I put no effort into this. Anyone notice this? Like, why am I giving stupid names? You wouldn't actually write code like this. I do it to illustrate a point that you need to understand, right? That regardless of what things are called, what do they hold? What do they point to? Being able to follow that data flow will be crucial in your ability to solve problems, right? As a junior dev, when you ask for help, you're going to say, hey, such and such isn't working. But when I do the following, it works. I've narrowed down the problem to X, Y, and Z, or just X and Z. And I need help figuring out if it's this or this. That's roughly how your request for help will go. If you're a good dev. If you're a bad dev, you're going to say something like, oh, I don't know what's going on, or I do this and it just breaks. No one can help you given the second scenario. They don't have time for you, but they might be able to help you given the first scenario. Does that make sense? Key thing to remember just from that little spiel is being able to follow the data flow. I did this on purpose. Right? This is molt, but this could have been donkey. Obviously, you wouldn't name a function donkey because you don't know what it does, right? Oh, function monkey is actually multiplying. I'll call it, multiply or molt or something, right? But I did it specifically so you follow the train of thought. Because that skill, the ability to follow data across your application, that's how you debug. That's literally the crux of the whole thing. Where does your data get stuck? Where does it break? Where does it stop going from A to B to C? And that's where your error is, right? Boom. So there you go. So yes, you can add, so here car is just a parameter name, right? But ultimately it's going to add a car class to this, another class, a car collection, right? But this person, right, this really wealthy person, right, could have class card, a card collection, right? They can have a card collection and they can have a card's really confusing. I don't know why I chose that. But they could have a card collection too, right? And guess what? They can have class really big house. They can have a really big house, right? They can have a really big house with a card collection. And a car collection. Questions?
So I guess just to go off of Logan's question earlier, I guess so here you're kind of seeing, I guess when you pass off information through like inheritance or something, when you call back through a print or a or a functionality like that. So I guess my question is it better to follow the naming conventions like this right here that kind of allude to the class? Or is it better to differentiate those naming conventions?
I think you're overthinking it. Just name it what it is for right now and be able to follow the data flow. That's it. Once you're able to follow the data flow, it's nice to have descriptive variable and parameter names, but it's not required because you know how the application works. Like the variable names is not going to break a bad program. I mean, a good programmer, right? Bad variable names will hurt a bad programmer, but a great programmer figures it out. Does that make sense?
Yeah, yeah.
If you understood this little flow here, you're in good shape. This should illustrate exactly how big applications are built on a very small level. I literally just made all this up, right? Just created a car class that had an engine, but then I started, adding collections, and then this guy's wealthy. He has got a couple collections, added a big house. I just made this up. You can too, and you'll have an opportunity. Okay, PyTest. Let's look at your first assignment. App users is your first assignment. This is really easy. You're just going to be asked to create classes exactly like we did here. So this one's really straightforward. I'm not going to go any deeper than that one. This one's going to be a little bit more challenging. You're actually going to build a terminal game. It's just a guessing game where you punch in the number, right? And your criteria is here. Right? It's just going to be a terminal game where you try to guess a number and it tells you if it's low, if it's high, if it's correct, and then it exits out of the game. And I think we'll get through this. I have another assignment that I just made up where we'll do an extension of the bank account class. We'll do an ATM game, which will be very, very similar to like a real ATM. What happens when you go to a real ATM? But these are just examples. You can extrapolate it out to, pretty much any application. So I would like, this is not going to take you very much time at all. So do this individually. I'm going to open up the breakout rooms here and then give this a crack individually. But after a little while, I'll bring you guys back, probably like 30, 40 minutes. I'll bring you guys back, right? And we'll see how far along we got on the guessing game. And if we didn't get very far along, we'll walk through it together. If we did, we'll move on to the next assignment. Make sense? Just a tip, your first assignment, I believe your first test is OOP, I believe. Stop share. And I just kind of beat you down for a couple hours on OOP. But now you get to work on it on your own. So yeah, that's going to help you out. Any questions about the guessing game specifically? Or if you have code, even better, actually.
I couldn't get the solved function to actually work without having the user input first.
Who's talking right now? Sorry, I can't see a lot of.
Nicholas.
Nicholas, can you share your screen?
I can.
Alrighty, go towards the top. All right, so you created a guesser game and with an answer, and you have some logic for guess, and then you have some answer for solved.
Yes. So if I remove this one.
Okay.
It helps if you save it first. And then the solved works.
Okay, so good. What do we really want to do here, right? You're guessing a bunch of things in order right there in line 30, 31. This really should read more like a terminal game, right? So that's the first thing that I would do after writing the class. How do we begin to do something like that?
You mean to make it read like the guesses?
Yep, like the README.
Which is this right here. Or I don't think I understand your question exactly.
Okay. So right now we want to take, eventually we want to take, this is good for developing the logic for the class and everything, but ultimately we want it to read like a game, right? And you
So
want to
you're talking
take,
about going here?
no, you don't have to
how it
mess
comes
with that
out?
right now. You don't have to mess with that right now. You want to take input from the user. Did everyone get to that part or no?
No, I didn't get to that part yet because the initial part told us to even just do this. And then it goes into doing the random generator.
Okay, so we can take it that right there. So what is your question here specifically then? We'll take it from here.
Because I can't get game.solved to return false when there is no user input, which I guess you need this to start it.
There you go. You answered your own question. That's what you're missing. You're missing the interface.
Okay.
That
makes sense.
Yep. So all of this works. Now you're on to part 2.
Got it. I was lost here then because it was before part 2 and it was telling me to make it be false just from the start.
Yep.
Got it.
And I'll actually go ahead and like walk kind of how I would do it, but this is pretty straightforward, and then we can break for lunch. Let me just start it off for those people that haven't got to that part. Alrighty. Can everyone see my screen? Yeah?
Yep.
All right. So let's do just game. PY. Alrighty. How about if I started with nothing? Right? I started for nothing, but I want to create a terminal game of some kind, right? And this is going to be super primitive, but it's all code that you can reuse. You can literally start like this, right? Hey, guy, welcome to my number guessing game. Python. Game.py. What did it print?
That's string.
Yeah, just a string. Hey, guy, welcome to the hey, player 1, welcome to my number guessing game. Did anybody know how to take user input?
Yeah, set a variable to input to equal input parenthesis and then your string inside of it.
Okay. And then I can just print user input. And this is kind of expanding on, I think, Nicholas. This is pretty much on Nicholas. This is his next piece. Do you have to do it like this? No. But this is literally as basic as I could make it, right? So now if I run my game, what's going to happen? This is literally my game. It's 3 lines.
It's going to ask you your name.
Okay, let's see. It's going to say, hey, player 1, welcome to my number guessing game. What is your name? Right. And then I can, it's really bad UI, right? Like there should probably be a space there, but whatever. I can do Max and I can hit enter. And look, it printed Max, right? But this could be a little nicer. This could be like, hey, what's your name? Cool. And then here, right, I can literally just copy paste, right? And now user input after he inputs it, right? I have that name. I have that name now, right? So I could say, welcome. Welcome, user input. I hope you are ready to play. All right, cool. Hey, player one, welcome to my number guessing game. What is your name? My name is Max. Welcome, Max. I hope you're ready to play. That's the end of my game. Yes? That's the beginning of my games. Now, granted, do I still have, what I have? I've built a simpler guessing game, right? I still have a lot going on, right? Like ultimately, I want this, and I literally just took this from the README. And okay, cool. So I know I'm going to have something like this. Cool. I can use it as a shell. All right, random. I'm not going to use for right now because it's too complicated. And I can just, actually, I can delete this for right now. And let me just follow the steps. Okay, define a guessing game class. Okay, class guessing game. Guessing game. I saw a couple of you put parentheses. You could put parentheses, but you don't really need it. The parentheses is typically if you're inheriting a class. So this would work. And then here I would create my init, right? So, and then I can do answer. Let's do answer, and solve. Sure. And then it would be self dot answer, and then self dot solved. And then I can just do true or false, whatever. All right. So I actually have a guess number class. I have a guessing game class. Do I not? Yes. I can go in here, right, and start creating. All right. So from that class, I could just uncomment this. Okay, game, guessing game. I got rid of this because this is too hard. I'm going to punt this in later, but it creates this class with, actually, I could get rid of solved here. This is a little bit later. I can just solve it with an answer for right now. So it creates a guessing game with just the answer. And for right now, I want to know what the answer is because I'm busy developing this. So we're just going to make it 10, right? Yes? Okay, cool. Last guess is none. Last guess is none, and then last result is none. I can leave that for right now. Let's just actually start here. And this is where all of you will start, right? So my code is I created just this game, right, that takes in the answer, which at this moment is 10, right? Game has a solved feature, has a solved method, right? So I'm going to need a def solved, right? Solved. Method of some kind. And then I'm going to just return, great, you solved it. And actually, it doesn't really matter what it is at the moment, right? And then if this function runs, right, and it's equal to false, do this stuff, right? What do I want to do first?
Create the variables for last guess and last result.
here they're set to none. This is actually a problem one of you ran into, right? What's bad about setting these to none initially? You're going to run into what here?
Different data types.
Different data types, right? So this is actually also a mistake. This should be probably an integer to make it a little easier on you to know, hey, now they're integers that we can compare, right? So also make that change. That's going to make your life a whole lot easier. All right. So now my game is trying to kind of look up, right? I mean, it's very bare bones. It has just the answer, right? I have one function that returns a string, which isn't going to help me, but for right now, it's fine. I have these two variables. I have game that I've hard coded to 10. Right now, I have a while loop that says, hey, when I run this, if this equals to false, and this condition is not true, say, hey, your last guess was this, right? Print whatever. But that's where this code can kind of start coming in, right? So this is obviously not going to work, but this is kind of how you start creating the game, right? I'm going to run game now, right? And it's going to run from the top. It's going to create this guessing game class, right? I'm going to instantiate one of them. I'm going to set these two variables. Then I'm going to get what from the player?
Input.
Yeah, I'm going to get their name, right? It's going to print out some stuff, right? And then it's going to go into this while loop of if that specific guess is correct. Let's run it, see what we got.
But do you have any place where you're asking for the number?
Yeah, no, I haven't, but I'm going to get to that.
Okay.
Right,
It's going to be an infinite loop.
Is it?
Yeah, because it's a while loop, and if it's false.
Let's just run and see what happens.
Okay.
Okay. Hey, player, welcome to. What is your name? All right, my name is Max. Right. It's going to say, welcome, Max. I hope you're ready to play. Right. It says, I hope you're ready to play. And then it tries to hit this. Is it hitting this?
Game solved is equal to false. What is game solved? Where is it defined at?
Right here.
It doesn't equal false then. It just equals great, you solved it.
Why is this happening?
So it's nothing. It's not defined as a Boolean.
So what's the issue?
You need a return line.
Not quite.
Gonna match
my code is hitting this.
Is it the self.solve commented
It's
out?
the none.
Well, those are different data types. Let's just do trip. Just return true for whatever. Okay, if it returns true, what's going to happen?
It's going to end. It's going to print out. There's nothing. It's not going to do anything because it's
not doing anything. What if this is false?
Then it's going to keep looping because it's going to always be false, probably.
Is game solved returns false? Does that you always equal false? Max?
Thanks. Yeah,
and
it's an infinite loop. Yeah. Did you do Control C?
Yeah.
Okay.
But here, I know that now gets me right into this loop, and then I start building out what the answer would be. Right. So this is the last thing that I'll leave you with right before we break for lunch. Right. It says, "Hey, welcome, welcome, Max. I hope you're ready to play." Right. And then what needs to happen after this?
Need the user input.
Yeah. right? We really, really like, we really would like a guess from the user, right? So how about let's go user guess, right? And all user input is passed in as a string, right? So if you want an integer, you need to cast that as one. So cast all of it as an integer, right? And here, you can just print user guess for right now. User guess for right now. Cool. So now I'm actually just going to set this to true for right now because I don't want to go into that loop. I just kind of want to walk you through every line of how you start building this, right? So now I go build game, it goes again, it wants my name. Cool. Welcome back to Hope. What?
What?
Oh, what is your
On
name?
input.
Yeah, you didn't change it.
Yeah. Pick a number. How about that? Pick a number. Cool. So Control C will exit it out of your terminal. Here we can run it again. Here we go. Run my game. Okay, what is your name? My name is Max. Welcome, Max. I hope you're ready to play. Pick a number. Okay, I pick 9. And then it ends. Right? It ends because the next line that my application hits is this while loop. And this, right, isn't true. So you take it from here. Right? So everyone's application will eventually look something like this. Make sense?
Mhm.
Just walk through it, just like that. I can copy and paste this. I mean, this is, I think someone asked me for notes or something. Who was that? I don't really keep
That
notes,
was
but
me. Yeah, and it's just only because I can't have the dual thing up right now to kind of code along.
yeah,
So
I will post this. I'll try to be better about posting. But if you need something, let me know. And if I have it like that, I just randomly just type whatever. I typically don't keep it, but yeah, I'll post that right there in the channel. But that's more or less how you begin that if you haven't. And if you already finished, no one's finished the game, right? The number guesser game. All right, cool. When someone finishes, definitely ping me on the side, and then we'll have you present. But that's more or less how you do it. I know I ran a little longer. It's 12:04. Let's come back at 1, grab lunch, and then we'll be back at 1. And at 1, actually, we'll go into breakout rooms again. But this time, I'll do pairs, and I'll post the pairs on the channel so you guys can continue with number guesser game. That make sense?
All right, is everybody able to see my screen?
Yep. Delete the.
Okay.
Close the README though. The README from the lesson. I just want to see your code. That's it.
Okay, gotcha. Let me pull up the one that he All right, so this is the one I started off with, but this isn't the one that he did. His is on the sorry, let's see. How do I forward redo? Up there. I'll just pull up the fork. He did create a fork for me, so just pull that up real quick. Oh, that's the one I created. Hey Scott, I was trying to pull up the fork that you had shared with me. How do I pull that fork up that you shared or collaborated with me?
Did you accept it?
It's in the top
Oh,
right
that's
next
right.
to your
Email.
picture.
Oh, there it is. Sweet. Okay. Accessibilization. All right, just learned something new. Awesome. This is the first one I've accepted. All right, cool.
And you'll probably have to change branches.
Okay, you know what? I'll just create a new fork, do this whole thing real quick. Sorry. I'll do this real quick.
You can create a new one, just change the name. We're saying.
Just show us the code, guys. This is getting way too complicated. Just pull up his one file and then walk us through it. That's it.
All right. Let's see.
Go to Scott Dev. Change branch to Scott Dev, and then it'll be in the
Gotcha.
the instructor guessing game, the one that we got help on.
This one right here.
Yeah.
Cool. All right. All right. So this is the one that basically that you helped us out on, and it does show import random here, but we didn't pull any. We didn't really use this at all. So we created a class here. Within the class, there was actually three different functions that were created. The first one being the init. That was pretty standard. We did a two parameters, one being the winning number and calling itself here. This here we put down last game equal false, and the reason being is because we're going to use a while loop later on down here, and in order for us to be able to continue to use this this function or this class is we want to keep it false until it returns true. So the second function we have here, we called it the guess function. This one is it's a user guess. So it's the one that basically it's the we have a zero here, but honestly, I don't even think we needed that zero here. We found out later on down the road. But the user guess is actually it gets used and it gets inputted here. So it'll ask the user like, put in a number, whatever the case may be. And then it puts in a number, and then it then checks it here. If it's less than the winning number, which we called here equals winning number, then return it false or too low. Same thing here. If it's greater, then it's too high, false. Else it'll it means it's correct, the guessing number, and it returns true. Then the other one is it's a solve function. So with this one here, what we're saying is return the if for this solve function is we're using last game one. I'm trying to remember how that one. You might have to take over this one here, Scott. So last game one was. Okay, here we go. So we go down, if we go further on down, so the last game one was false here right now. But if you go further down here, we have a new variable called current game. And this actually is, we put 10 as the parameter being the, basically the winning number right here. So right now we have the winning number is 10. We didn't really need this one, so we put a while to. We say, hey, right now, if the current game is if the current game solved, so this function right here is equal to false, then what we'll do is the user guess is going to be. Then we'll ask the user to input a new number and keep guessing, basically. So then it'll keep guessing, and then it'll do the check with the guess here. It'll run this function again. If it's false, it'll kind of go through again. But if it's one, if it's true, then basically it prints congrats. And that's as far as we go.
This is a pretty clean solution. It's very short. There's a couple other solutions out there that I saw. They're a little longer, but just as accurate. Any questions about how they solve this or the general idea here? This is actually really important. Look at this closely. Your answer could have been different, right? But conceptually, everyone should have all of these pieces.
I do have a question about my group we we just took an input at user guess, and I think you didn't want it there, but I'm a little bit confused, like, because we had our user guess outside the loop, but we were actually taking input at that line. So you were just wanting us to set that to 0 and not take input?
So here's the thing. The readme's kind of a little wonky. It should have been in the loop the whole time. Now, had you put it outside of the loop, it's fine. It's fine for right now. And like I explained to a group uh, earlier, ultimately, you know how remember I told you that everything's encapsulated and you're never going to have just a little loop hanging
Right.
out by itself? Remember that? Notice
Yeah.
what you have at the bottom here. You have just a little while loop hanging out at the bottom.
Right.
You're never going to have that. The only reason why it's happening this way is, hey, we're teaching you with one class.
Yeah.
Eventually, I don't want to confuse all of you, right? But eventually, when I was typing, or your user, right, you asked for the person's name, Max or whatever,
Hmm.
right? Eventually, you'll have like a user class,
Okay.
right? An instance of games, right? And you ever play like PlayStation or Super Mario, you can have like 10 different versions of the same game saved on your console, right?
Hmm.
Those are all will be versions and instances of that same game, right? So that's kind of conceptually the idea behind it, right? Everything should be encapsulated. It's okay if it isn't, and if your user input was outside the while loop for right now, it's not that big of a deal as long as you conceptually understand that eventually it won't be like that.
Okay. Yeah, I was just kind of confused at because you said make a certain change, and that just kind of completely threw me off because I wasn't sure. But now I see it. It's outside the loop here. So
It's not. They're not using line 30.
they're not using line 30.
No, it's
So
just
I
there.
mean,
They just forgot to delete it.
so user guess. So I mean, if you don't define it there, then it's gonna throw an error because it's going to say user guess is not defined.
No, you're defining it inside the loop.
Yeah.
Say that again. Oh yeah, yeah.
Yeah, you're defining it
It's
there on
defined.
line 32.
Yep.
Mhm. Scott, can you run your code on your screen? Could you share on your screen since you have it on local?
Yeah. So I was reworking this so that we could have the whole thing, but so it's still hard line or hard coded to 10. And so guess a number, 5 is too low, 2 is too low, and 15 is too high, and then 10, you get correct. Congrats, you won. Um, and then, so this is the more current one, like Jose said, and I think Guillermo mentioned it too. We just didn't delete that line yet. When we were starting to try to go through and clean it up, we realized that it wasn't being used at all. So it's not in this version of it. I just haven't pushed this up to GitHub yet. Was there something specific you wanted to see on there, Logan?
No, I was just wanting to see it run without the declaration of that variable outside of the while loop, like Brian was asking.
I just didn't have it. I Okay, I see what you're saying. All right. Yeah, because I was trying I it wasn't working in mine because I was using a guess and an if statement before I defined it. But I don't even need that line, so I can get rid of it.
Any other big questions about that? The guessing game?
I saw that they used faults as like the base instead of, I don't know, the way I did it was changing outputting correct instead of just having like the default at faults, and so the whole code hinges on faults instead of. I don't know, I'm not saying that right, but
Can you share your code?
yeah, it's like I saw one way, or I thought of one way of doing it, and then just went with it. So I had I had like I tried to Google figure out how to get like a variable inside there. So I
Mhm.
had like a variable in there, and then did let me see. Yeah, so it's like I had one input here where, and then it goes in here to user guessed, and then if that current guess is correct, then it puts result, puts the results correct, and then if not high low, and then going into the while loop, and then it'll do like, oh, it's high or low, and then but then I would have to have another user guess to like start it over. It would just be a endless loop. But I mean, it works. It's just not as clean.
Okay, so this does work in every use case.
Uh, I don't know every use case, but
Don't run it to 1,000. Just put
yeah,
like 5 or something.
yeah, I
Put the
know.
hardcode
It's like,
5 right there, and then run it.
and then it's okay.
And just delete that rest. Yeah, there you go. That too.
Yeah, so it'll last guess was
Yep.
low. Or it's high.
Perfect. This works.
Yeah.
This works. Ultimately, this is awesome if this is what you came up with. And eventually you would just get to a point where just refining the code once you solved it,
Yeah.
right? Like for example, let's look at your init right at the top.
Mhm.
Let's at the init. He's taking in answer, right? But then he's not taking in result or last guess, and he's just leaving them there, right? Without them being instantiated when you create the class. Not really the best thing,
Yeah.
but that's okay. You wouldn't do it that
Okay.
way. But
Yeah.
more or less, the main thing with this answer is just it's a lot of extra code that you didn't really need. Like for solved
Right.
is a good example, right? You have a lot going on
Yeah.
there. A simple return what
Right.
the current status of solved is would have been just fine. But yeah, once you solve this, you realize that
Okay.
this works. Then you go back and you're like, okay, well, how can I improve this? And then you work on improvements.
Okay. Cool.
Good. Nice job. That's actually a really good answer too. Alrighty. Before I give you the last assignment, that's actually not a README. It's literally just going to post it in the in the Slack channel. I just want to go over just one last thing that I forgot. Here. Cool. All right. Can everyone see my VS Code? Yes. Alrighty. I talked about the four pillars of OOP. Again, you don't need to know all of them in depth right now. You're going to see a lot of them, and some are actually a lot more prevalent than others. So keep that in mind. The last one that I didn't actually really touch on was polymorphism. So I created this little animal class, right? And I just want you to just study it based on everything that we've discussed so far, right? I want you to study this class, these classes, and we're going to discuss them here shortly. I'm just going to ask you to tell me what's going to print when I run this.
I think for this one, it
Oh.
should do per cow like moo, meow, and then nothing.
Is this right? Line 28?
Wouldn't so I was kind of reading about the polymorphism on the guides, and wouldn't it print like James and then cow noise and then Felix cat noise and then Benji dog noise?
No. But line 28 is pretty close.
Instead of nothing, it should say rar.
Yes.
Uh,
Let's look at it. It says poly. Moo, meow, roar. Let's walk through it. This is more or less polymorphism in a shell. Right? I have a class animal as a name, and it just has a name. To instantiate or create a class of animal, you just need a name. Cool. It only has one method outside the basic init method, and it's speak. And it returns just a hard-coded string, just roar. Cool. Then you have two classes. Actually, you have three classes that all inherent from animal because cat, cow, and dog are all animals, right? These both have speak, right? Even though they inherit from animal, if they have their own method called the exact same thing, it actually overrides it, right? So it takes their meow, right? It takes the moo, but in the absence of it, it defaults to whatever inherited it from.
So if you took out the override of speak, they'll all say rar. Like if you took out def speak for the cat and the cow, then when you say speak for any of them, it should say rar.
Yes. Then it would just mimic dog class, right?
Yeah.
This is just an example of the same method, right? Acting upon different instances of objects, right? And getting a different outcome. Method is called the same, but depending on what you're acting upon decides, right, what the output is.
So it's not displaying the name because we haven't created a method to display the name?
Yeah, but help me out. Let's create, let's do it. And here, I know that I can get, instead of speak, I could say name, right? Say name.
Just say name.
There you go. And I can actually run this.
Uh-oh.
And I got an error.
Name.
What's the error?
There's no attribute for cow.
Cow.
That's called say name.
Yeah, cow doesn't have say name. So I'm iterating. I'm trying to call this method that actually doesn't exist, right? It doesn't exist on anything, but it only exists in Felix, right? It only exists in Felix, right? So if I made that just a one element array list and I ran it, right, it should return catman.
Uh-oh. Cow is not defined. Oh yeah, you deleted the class. You commented out the cow class.
Did I?
Yeah.
Oh. I did not mean to do that. I meant to do this. All right. Let's try that again. So with all the 5 pillars, right? Or is it polymorphism that I just described? Composition, the idea that classes can have other classes in them, right? The idea of inheriting from one class to the other, right? You see that here, right? And the idea of abstracting and encapsulating, those are your 5 pillars. If you have a very loose understanding of all 5, that's fine. Honestly, if you just understand honestly, the first 3, I think you're gonna be fine. Inheritance, abstraction, and encapsulation. Ultimately, to be really great, you need to understand all 5 of them, but for right now, loose understanding will be just enough. Make sense? Right? All right. So out of the 5 pillars of OOP, if I press this button right here to run my code, what's that an example of? Out of only the 5 things that we discussed, when I press this little button right here, top right hand corner of my VS Code to run code, that really closely aligns to which pillar?
Abstraction.
Abstraction. Don't do it. I saw a couple of you do it. Run everything via terminal. Trust me. Right? I think I would argue that I think there's probably more code in the world that's run on servers without GUIs, maybe than computers with GUIs, probably is my guess. It wouldn't surprise me if that was true. Right? So then the terminal becomes king. Right? When you press the button, you don't know what's happening. You don't know if you're executing a file. You don't know the entry point of your program. Right? You don't even know if you have the right permissions for said file or said execution. Right? It abstracts everything. Right now, we need to not abstract too many things and get down to the heart of what's happening in our code early on. Okay, cool. That was that last one. That's all 5. And here's the last lesson that I have for you.
Before we jump on next question, I
Yep.
have a question. So in the beginning of this code, the line 30, for name in paid list. So when you print name dot speak parentheses, and then we call the speak function, right? And then name in the paid list, and the paid list only has a James, a Flex, and a Benji. But so at line 6, the return is raw, right? But that function was not be called in that list. Why do you still have output the raw will be printed out?
Because cat inherits from animal and so does cow. So they have access to this method. They have inherited that functionality.
Yeah, so the cow and the cat and the dog should be printed out, and because from my understanding, I feel those are the 3 class or in the list, but the line 6 is not in the list. Speak, right?
Does James have a speak method?
Yeah, this will be
James is a cow.
the cow.
Does James have a speak method?
Yes.
Yeah, it inherits it from animal.
Okay, thank you.
Did everyone understand her question?
Yes, I was actually confused on that too when I was reading about the polymorphism, because I know there's 2 types, right? There's the class polymorphism, which is what's happening here, but there's also the method polymorphism, right?
It could be.
There is only class polymorphism, right? That thing about overwriting right? That's kind of a separate topic altogether. I don't want to get into because then I would have to introduce the super method, and that's outside of the scope of today. So just
Python,
think of it as class.
you can overwrite methods in Python.
I just did it, didn't I? Which, if you really think about it, conceptually, it makes perfect sense, right? Because I'm inheriting to ultimately write less code. But a cat and a cow don't speak the same.
Right.
So a cow should moo and a cat should meow.
Yeah.
But I shouldn't have to give, I shouldn't have to give these three animals a say my name method because all animals, as far as I'm concerned, have a name.
Right.
So that can be passed down. Right? It doesn't matter if you're a cat or a cow, right? Your name can be Felix. It can be anything. I think polymorphism is probably the hardest one to understand.
So like if you wanted to do something like, well, let's say you own like some sort of like a shelter, right? You would want your class inheritance to go back to like maybe like on the top, vaccination status or like previous owner amount people, right? Uh, and maybe that could be something that it all shares, right?
Your question is really broad, but I'll try to answer it to the best of my ability because this actually kind of leans into the lesson the assignment I'm about to give you. So this is not the assignment that I'm going to give you, but that makes for a good exercise. So I'm going to do this very quickly. All right, lock in. I've been talking for a long time now. Class animal shelter. Class animal shelter, right? Would have what?
You would have animal type
No,
or species.
no. Think bigger. An animal shelter. Just think of an animal shelter. I'm sure we've all at least driven by an animal shelter. An animal
The
shelter
building.
typically has what? Yeah, it has a building, but it also has, hey, I'm going to an animal shelter, right? They typically have a what?
An
A
address.
name,
A name.
a name, an address. Why not? Let's just do that.
Animals.
So give me yeah, chill. We're getting to that. Okay, name. It's got this animal shelter has a name, right? It's called Cats Save Our Us or whatever. I don't care. Whatever. Address, right? It has an address. And it's 123 Fake Street. Right? That's it. That's the minimum thing an animal shelter can have. Right? But guess what it can also have? It's an animal shelter, so it's gonna have it's gonna have what?
Animal pens.
Did someone say animals? Yes.
This class is
It's
getting harder.
yeah. It's going to have, right, animals.
Oh,
And
great.
it's gonna have a lot of animals. So if we created a list, it'd be kind of hard to let's just create a list. All right. It's gonna have animals, right? Oh, sorry, I haven't given this is address. Address. I can't spell apparently address. Okay, cool. So that's kind of the bare bones, right? I have an animal shelter, but yes, in here, right, I would have class animal, right? And in here, yes, you could say, you could kind of go into, really deep, like, species, color. I don't know anything about animals, species, color, cute. I don't know, like cute or not, I don't know. And then you start just going into this, right? But then a subclass of animal would be class, dog, inherits from animal, right? Yes? Yes?
Yes.
You could even have class dangerous inherits from dog, because all dogs is dangerous. No, I'm just kidding. But you could take it that way. Yes, you're going to do something very similar here, but I'm going to give you a brand new exercise. Yes. Okay. I'm going to post the requirements here in the channel, but the only thing I want you to think right now is think of walking up to an ATM. Just think about it. What does it all entail?
PIN number.
Just all entail, right? I just put the requirements on there. I'll go ahead and throw them up on the thing. Right? And you are going to fill in these requirements. So this is the ATM challenge. So there's no readme for this. I just made it up. So this is ATM challenge requirements. I'm walking up to an ATM, right? So I'm just going to pseudocode this just to get you started, right? But I'm just going to walk up to an ATM, and I know, right, that I am going to walk up to what?
User interface screen.
Yeah, some kind of user interface screen of some type, right? And then they're going to do what?
Search your card.
Card into the machine.
Insert card. So you're going to have to fake, hey, insert card or whatever. All right, I'm going to insert card. Jesus. I'm going to insert card. Then I'm going to
Put PIN in.
PIN. Then
Select cash or approve. Select amount or approve
Transaction.
Man, it looks like we've never gone to an ATM. Select option. Select whatever option, right? You can deposit money. You can take out money, right? You could do a bunch of things. You could check your balance, I guess. No one does that. They just do it on their phone. But select whatever, right? Deposit money, withdraw money, balance check. Although they might have gotten rid of that. I don't know. Balance check, right?
At the ATM, they don't. You can't balance your check at the ATM.
No, balance check. Check your balance. Can you do that
check
anymore?
you can
Yes,
check your
you
balance.
can do that.
Okay.
You said balance check.
Yeah. All right. So check your balance, right? Choose some option, right? Bank account must update based on actions performed, right? Ask you if you are done. And then the last thing is confirm logout. Right, something like that. Right? This is a little more complicated. Hard code these values, right? This is a bunch of print statements here. This is user interface, a bunch of print statements. You can put them outside of the loop, inside of the loop for right now, whatever, right? There's going to insert card here. There's going to have to be some kind of user interaction, right? That validates card is, inputted, whatever, inputted. All right, it's going to pin. Here, this one's a little more complicated than the other one because here you're going to have to validate if pin is accurate, right? If not, reject or give maximum number of tries, right? Before they freeze your card or whatever. Yes? I don't know. I've never tried it, but I imagine if you press in the pin 10 times, it's going to lock your card probably. I don't know. Never tried it, but I imagine that's what happens. Okay, so pin, you're going to have to validate that, right? Then you're going to have to give access to the options. Then you're going to have to act on all the options, right? And then ask you if you're done, confirm logout, right? And then to check again, log back in and check. And this is kind of a stretch challenge. Log back in and check if your balance is correct. See if anyone can figure that one out. I'll add these two. I mean, I don't know how helpful this is, but I'll add this to the little post that I made in the channel. Questions?
So it's going to be multiple classes, right?
Great question. Let's walk through it. What's your top class?
User.
Ooh. Let's start easy. Let's start easy, right? Hey, if you can only, I'm going to say this right now. I just made this program up. I just made this challenge up. If you can only do one class, stick with one class. Now, if you can break it up into multiple classes and make it really high speed, that's a stretch goal. Yes? For this
Yes.
goal, I just want the while loops and one class. However, the right way, and whoever said that, I think it was you, Scott, eventually, yes, all of this becomes classes, right? So, right, you're going to have a class ATM, right? You're going to have a class ATM, and I just want you to start there. But if you're really high speed, eventually you can have a class user, right? And I'll leave it at that because that's already probably way too much. I'm going to stop sharing. I definitely just talked to you for way too long. So definitely it's 3:27. Let's come back at 3:50. Let's take a nice 20-something minute break. Let's be back at 3:50 and get back into those same groups. And then we'll do a wrap up around right before 5. Make sense?
All right.
All righty. All right, guys. How far did we get on that ATM exercise?
Not far enough.
Not far enough. You mind sharing with us by chance, Scott? Just kind
Sure,
of
just no
walk us
laughing.
through. Yeah. Just walk us through kind of what your thinking was, how far you get. That's good enough.
Yeah, so I gave myself a fake piece of data just to work with, and this is me checking to see some math. Um, Working on getting the balance right now. So have a class called check balance. It's going to get past an account, and then the function is get balance, and it's also taking the account, and then it's going to, if the account is checking, it's going to pull the checking balance, and if the account is savings, it'll pull the savings balance. And then we have a single class for deposit and withdrawal.
Okay, pause right there.
Yeah,
Pause right there. What are you trying to do on line 52?
troubleshoot with the print statement.
Okay. Anyone besides Scott, what's the issue with line 40? Scroll up a little bit. What's the issue with line 52 here? You can scroll up a little bit in your, there you go. Right here. There's an issue with line 52. Can anyone find it? You only have to look at line 37 to 52. That's it. And the problem is on line 52.
He needs to put a F in front of that. No?
What's that?
Uh, F.
No,
Like make it an F
no,
string.
no.
Sorry.
The F string
No,
doesn't
He's
matter.
got he has the account parameter, but so he's running checking into I don't know, this it's not, oh, if account equals checking. Oh, never mind.
Is
I'm
that
gonna wait.
because
Go
Tired. Sorry.
ahead, Julie. No worries.
so like the print 51 or 51, right? So that's a variable, update the balance of variable, but he didn't call the function, so the input or the data cannot pass to the function, so cannot be called. Is that right?
You're kind of close, but not quite there. The problem is on line 52. What is wrong with line 52? Look at it very closely. It's the first word. What is wrong with that word? It should be returned. No. What is check balance here on line 52?
The class.
Class.
You didn't create an instance of check balance. There is no instance of check balance. That's the problem there, right? So it should be something like lowercase check balance equals check balance, and then create that class with the account number, right? You can't call a method without the object. Does that make sense?
It does, yeah.
Okay, cool. Keep going. I was just bringing it up to everyone. You can keep going. This is fine.
But no, that was pretty much as far as we got.
Okay, cool. Pretty good. Yeah. You started off. I think you could do it, Scott, but I want you to keep in mind the following. Typically, when you build a solution, start small. I think you almost started too big, right? You wanted to start with ATM, and then once you have everything, kind of, okay, there's an extra class, create the class, and then start moving some of your completed pieces over, and then see if it works with the two classes, right? Typically, what people do, I'm sure you guys have heard this, if you've done any research on the tech scene, typically people go too wide and don't go narrow and deep enough. Does anyone ever heard that? You can't learn everything in tech. It's too much. You need to focus on a very small subsegment of software engineering. Does that make sense? Right. I talk to my girlfriend all the time. She works on she works for GM. She works on the infotainment, where you press the buttons and you have your Apple Play and Google Play. She works on the firmware for that. When she talks about her work, I have no idea what she does. But when I talk about scaling a big application through serverless, just services, she doesn't know what I'm talking about. Right. Software engineering is really, really big. Does that make sense? Okay. So given that, you always want to start small. This is great, though. This is a great shot. If I was to give you an advice, is just focus on the ATM one and comment all this out, and then eventually add it in once your normal ATM works.
Okay.
And how you would do that is just hard code a lot of the variables right now, just so it works. And then, okay, then you make it dynamic and add your user class or add your other classes. Good though. This is great. You actually got pretty far for like an hour, less than an hour. Thank you, Scott. Anyone else get anywhere close to this?
I could input my PIN.
Let's see it. Yeah, let's see it.
And I was just broken, but
yep.
Mine's nowhere near. I tried to figure out how to make functions and things in there. Then I just started confusing myself and breaking what I had that
no worries.
was kind of working. So I basically just created this class that said the card was inserted, made it equal to true, set up the pin, which I probably didn't actually need this because I just define it right here as what the pin actually is.
Yep.
Gave it a balance, and then just so while the user pin, the input that we actually get, is not equal to the pin, it's just going to keep asking you for your pin. It doesn't break. It just keeps telling you it's wrong. It goes back. And then it'll continue down, and then you can get to your transaction selection. And then I got it to work where I could check the balance. It'll spit out the balance, and then it breaks because it doesn't cycle back like it should.
Okay, let's go up. This is actually really good. Let's go up. Okay, delete line 14. And you have an attribute in this card inserted class. Fix line 19. What's wrong with 19? Line 19. Just fix it right now. It's just self, right? Self.pin.
Oh.
Okay. You don't need line 18. Your user pin is the hard code right there. All right. And stop right here. Okay. This is really good because you're kind of on the right idea, but conceptually, this is why I say this is one of the hardest things in the program, because conceptually, you really have to understand what I'm about to say right here. Look at line 19. It says while user pin. That is functionality, right? While that is some kind of functionality. Why is that
Yes.
functionality in card inserted?
It really shouldn't be. I could only figure out how to keep it going essentially line by line to go correctly.
Yep, no worries.
I needed to figure out how to make it bounce between all the functions to keep it going through the process. But every time I attempted to move it in that direction, I would break the whole thing. So I was just kept going in line until I could essentially get it to work, and then I would eventually then try to split it to
Yep. No worries.
call it.
That totally works. When you're working through this, I'm a big fan of just always commenting it out. I think I did it with someone, just copy some of your code and then just duplicate it at the bottom of the file and comment it out. That way, if you're messing with it, you always have a copy of it. It's kind of like a Neanderthal way to develop, but for right now, that's totally fine. This is what I would have done. Had I gotten here and gotten really stuck, I would have just copied all of it, pasted it on a separate file at the bottom of this file, commented out, and then kind of started over. So right here, the class inserted really sounds like a method. It doesn't sound like a class, right? So that's kind of where your first mistake comes. And that kind of leads you to kind of come to the conclusion that, hey, why does card inserted class have this functionality? This kind of functionality sounds like what class should have it?
The ATM class.
The ATM class should have that functionality. Right. So I want everyone, I know I didn't give you a lot of parameters in this challenge, mostly because I just made it up, but start with the ATM class and then expand from there. Because even that one is going to be a little complicated. Right. But so far, if you change that name like you just did on line 11 to ATM, balance, you can hard code it for now. Pin is hard coded. Awesome. This is a good start to your ATM class. Right. And your ATM class can have a couple of print statements saying, hey, welcome. What would you like to do? Is card inserted? Is it not? And then you can take it from there. Yes?
Yes.
Understanding how to divide your application into these different components is a really crucial piece to this. And it takes a little bit of time. Right? I think a really common mistake that I saw in the number guesser application was some of the functionality that should have been in the number guesser class was actually inside the while loop, and vice versa. A lot of you made that mistake, yes? Right? You started adding the high lows inside your while loop, but wait, that's really functionality of the game, right? So the game should control that. Good, that's awesome. Thank you. Anyone else have one more person? Anyone else have anything? Notice how different those things were.
Yeah. Yeah, send a request.
I don't on
Yeah.
Zoom?
Like share my screen. Okay.
Oh, I don't think I have to approve it. You can share it now.
Okay, yeah. So Michael is like a baby right now.
Uh-huh.
Oops. I'm sorry. Yeah, let me try to.
Yep. No, this is great. We can see it.
Okay, you can see clear.
We can see it. This looks great. Go ahead.
So in the beginning, like I try to get some functions like deposit money and withdraw money and check the current balance. Yeah, it's very basic in the beginning. So and then later on, I saw like maybe I should put like a different option for the user to check, but I haven't got it there yet. So just like some print statement. Yeah, I mean the ATM, the number is hard coded for now. I'm supposed to take some input function so I can let the user to uh give their like a pin or something like that and check like how many digits can the user should put like when they tap the pin, right? Also how many attempts, but I haven't got there yet, so just a little bit.
That's good. Stay right here. Go scroll up a little bit. Pause right here. This is an almost perfect start to the ATM class, how I would have done it when I first started out. Notice how kind of like super amateur this is with all the print statements. That's cool. Get something to work and then you can refactor it. Yes, you could have done an F string with backslash ends and been super high speed with it. Yeah, of course, right? But this will do for now. An application that works is way better than a really cool application that doesn't. This is great, Julie. Nice job.
Thank you.
Notice all three of those very, very different approaches. They will all eventually look relatively the same and will work depending on how far they went with the number of classes that they used. But those are great. If you got anywhere close to that, you did a good job. Don't be afraid to just write a bunch of print statements and ask what, user input or whatever it needs just to start off. You eventually figure out that, hey, you have to move those inside of a loop or inside of a class or something like that. Then you just copy paste in the right place. Yes? This is the end of your first 2 weeks. If I had to give you any advice of the 3 things that you should try to understand, right, is your Python, your Git, even if your GitHub's not that good, your Git, right? And if you have any kind of decent understanding of what we learned today, that's it. Those are the 3 things. When you go and self-evaluate and you're showering, right, and you think, how well am I doing? If you have a general idea of those 3 things, you're going to be fine. Good? Good. All right, guys. Have a wonderful day. Oh,